In the last part of the lecture, we'll learn how to change the base of a logarithm. We already know that it's very easy to work with logs to the base 10 on the calculator by just pressing the log button. But if we were given some problem like find log to the base 5 of 16, we wouldn't be able to do that so easily because there is no button on the calculator that will evaluate a logarithm to the base 5, so we need another way of doing things. So we'll begin by writing 5 to the power of x is equal to 16. Now this should be recognisable straight away as a logarithmic equation, and we know how to solve them. We'll proceed as we did before, and we'll take logs of both sides, and as usual we'll use log to mean log to the base 10. So it'll be log of 5 to the x is equal to log of 16. Applying the laws of logs, we'll have x log 5 is equal to log 16. So therefore x will equal log 16 divided by log of 5. This we can work out on the calculator. Log 16 divided by log 5 is 1.72 to 2 decimal places. So what we've done is we've taken log to the base 10 of both sides of this equation, just as we did before when we were solving logarithmic equations. We've actually changed the base of the logarithm in order to work out the solution to 5 to the power of x is equal to 16. So in general terms, if we have something in the form of log to the base a of x, we can rewrite it as log to the base b of x divided by log to the base b of a. So b is the new base that we're converting to. There's a special case when we have log b of b, which we know is going to equal 1. So we can then write this as a reciprocal. We'll have a look at how we apply both of these rules in the following examples. In the first example, we'll consider the reciprocal case for the change of base of logarithms. We're required to solve log to the base 2 of x is equal to 8 plus 9 log to the base x of 2. Log to the base x of 2 can be written as a reciprocal. So let's start by writing log to the base 2 of x is equal to 8 plus 9 multiplied by 1 over log to the base 2 of x. Having done this, we can now make a substitution, and we'll let y equal log to the base 2 of x. So y will equal 8 plus 9 over y. Now if we multiply through by y, we'll get y squared equals 8y plus 9. So that implies that y squared minus 8y minus 9 is equal to 0. Well, that will factorise nicely. We can write that as y minus 9 multiplied by y plus 1 is equal to 0. So of course our two solutions to the quadratic are going to be y is equal to 9 and y is equal to negative 1. So let's go back to our substitution. Y is equal to log to the base 2 of x. So our first case will be log to the base 2 of x is equal to 9. So that implies that x is equal to 2 to the power of 9. So therefore 2 to the power of 9, as you all know, 512. That's our first solution. And the second case will be log to the base 2 of x is equal to -1. So therefore x will be given by 2 to the -1, which is equal to a half. That's it. Let's move on to the next example then. In the next example, we'll calculate log to the base 3 of 12.2. In this case, we want to apply the rule log to the base a of x is equal to log to the base b of x divided by log to the base b of a. It's just a simple case to apply this rule then. So we can write log to the base 3 of 12.2 is equal to log of 12.2 divided by log of 3, and that works out at 2.28, correct to 2 decimal places. In the last example then, we won't actually use the change of base rule, but we'll bring together a few different ideas to solve two logarithmic equations simultaneously. So our first equation is 8 to the power of y is equal to 4 to the power of 2x plus 3. And the second equation, log to the base 2 of y is equal to log to the base 2 of x plus 4. So a good starting place for us would be to rewrite the first equation in terms of log to the base 2, because we wanted to make it consistent with equation 2. So let's go ahead and do that. We can say that 8 to the power of y equals 4 to 2x plus 3 can be rewritten as log to the base 2 of 8 to the power of y is equal to log to the base 2 of 4 to the power of 2x plus 3. So that's our first step in the solution. We can now write this as y log to the base 2 of 8 is equal to 2x plus 3 multiplied by log to the base 2 of 4. But log to the base 2 of 8, well, that's going to be 3, isn't it? Because 2 cubed is 8. So the left-hand side will be 3y. And log to the base 2 of 4, well, obviously 2 squared is equal to 4, so that's going to be 2. So 2 times 2x plus 3 is going to be 4x plus 6. So 3y is equal to 4x plus 6. What we can do now is we can just rearrange that to write y is equal to 4x plus 6 divided by 3. Alright, so we'll have to move on to another slide, and let's just write that down again. Y is equal to 4x plus 6 over 3. And our two equations were 8 to the power of y is equal to 4 to the power of 2x plus 3, that was equation 1, and log to the base 2 of y is equal to log to the base 2 of x plus 4, and that was equation 2. Okay, so we've now found an expression for y in terms of x, and what we're going to do is substitute that into equation 2. So we can now write equation 2 as log to the base 2 of 4x plus 6 over 3 is equal to log to the base 2 of x plus 4. That 4 by itself is causing us a little bit of a problem at the moment, but we can soon get rid of that problem because we can actually write the number 4 in terms of a log to the base 2. So let's go ahead and do that. We'll have log to the base 2 of 4x plus 6 over 3 is equal to log to the base 2 of x plus log to the base 2 of, well, it's going to be 16, isn't it? So therefore, log to the base 2 of 4x plus 6 over 3 will equal log to the base 2 of 16x using the laws of logs. We can now remove the log to the base 2 from both sides, so we'll finish up with 4x plus 6 over 3 is equal to 16x. And after a little bit of manipulation, we'll find that x is equal to 3 over 22. And by substituting that back into the equation, y is equal to 4x plus 6 over 3, we'll get y is equal to 24 over 11. And that's our two solutions. Okay, now have a go at the multiple choice question.